Hello and welcome back. Today we'll be getting into section 9.2 on polar equations and their graphs. So one option if we're graphing polar equations is to convert to rectangular. So if we have, for example, r equals 4 and we want to graph that, recall from section 9.1, r squared is x squared plus y squared. So here 4 squared is x squared plus y squared. This is just a circle centered on 0, 0 with a radius of r equals 4. Use the handy dandy stamper guy here. You don't need all of these angles necessarily if you're sketching by hand. If you're sketching by hand, I would definitely start with the pole and the polar axis, and then maybe just kind of identify for yourself where the sort of compass positions would be from there. And then here's our sort of pi over 2. Here's our pi, 3 pi over 2. And then every 30 degrees, so basically in the 1 o'clock position and the 2 o'clock position. So here we're going out, so this was made, someone that was a little bit more familiar with manufacturing than Trig. Their first circle, unfortunately for me, this stamp, this one had a radius of 1/2, and all the other ones had a radius increasing by 1 each time. So this one didn't quite fit the pattern, so if I want to count by ones, I've got to do half steps each. Anyway, so I'm going out to 4, so here's 1, 2, 3, and 4. And I'll just kind of identify the 4 on the compass points, and then just sort of connect the circle up as best I can. Again, I know you don't have necessarily all of the same equipment you would in a classroom in your homes. I don't either. So again, roughing it in though, so here's like pi over 6 is at the 2 o'clock position, pi over 3 is at the 1 o'clock position, and then halfway in between there is your 45 degree angle, your pi over 4. You should be able to get them reasonably good looking from just those few angles. Alright, so that's what a circle would look like. So next we'll take a look at polar equation. Theta is pi over 6. So recall that tangent of theta is y over x. So tangent of pi over 6 is y over x. So pi over 6 is our 30 degrees, so our y value is 1/2. Our x value, root 3 over 2. So then y times root 3 over 2 is worth x over 2. So y is worth x over root 3. So this is, as you can see, this is a line, y-intercept on the origin if you want to think rectangular terms, and a slope of root 3 over 3, or 1 over root 3. That one's actually a little bit easier, though, to sketch if you just do your angles on it. So again, you likely don't have a stamp like that, so just start with your polar axis, and if you want to pull it a little bit farther down, that's fine too. At least get your compass points in there. So pi over 6 is the 2 o'clock position, and it's going through the pole. So if it's just an r equals, you're looking at a circle. Just a theta equals by itself, you're looking at a line. So this next one, we have both an r and a theta. Let's see what happens there. So try r cosine theta is worth -1. Recall from section 9.1, r cosine theta is x. So basically this is saying x equals -1. So this one, I'll sketch the graph in the polar plane and just kind of use the tools that you would have. You'd likely have a straight edge at home. So get your 4 compass points going, and then just sort of rough out where approximately 1 o'clock would be and about 2 o'clock would be. Then you need a scale. So if you're going to use just your notebook paper for a scale, that's just fine. So here's our 1, 2, and 3, etc. You can scale it by ones or by a half each time, and then just kind of grab another sheet of the same type of notebook paper, and you got your horizontal scale as well. So in this one, we're saying x equals -1. So there's our graph. It's just a nice, pretty vertical line. Next up, we'll try r equals 5 cosine theta. So this last one had r's and cosines in it, and it gave us a line. This one actually won't give us a line, though, because the r and the cosine theta are not attached to each other like they were previously. But if I do put an r attached to this cosine theta, then I can say, okay, I can use that same translation. R cosine theta is x. But if I multiply the right side by r, I also have to multiply the left side by r. So r squared is 5r cosine of theta. So then we can do a little bit of substitution. Remember, r squared is x squared plus y squared. R cosine theta, that's the same as x. And we can just complete the square in this guy. So half of -5, square the result, 25 over 4. So we have x minus 5/2 quantity squared plus y squared is worth 5/2 squared. So this is another circle, actually. Circle radius is 5/2, and the center of this is at +5/2, 0. So again, I'm not going to assume that you have the same exact stamping equipment that I bought. So I'll try to do a few the way you would have to do them. So this one, we don't have really any work with our angles going. We know this is a circle, we know the radius, etc. So I'll just go ahead and set up my scales as if this were being graphed in the XY plane instead of in the polar plane. So 5/2, remember that's 2.5, so 1, 2.5. So there's our center, and then our radius is also 2.5. So 2.5 back the other way, we go through the origin, and 2.5 this way, we land at 5. And then 2.5 up and down. So that should give you enough info to sort of rough in a reasonably round circle. Sometimes, like mine, yours will come out a little lumpy. As long as you're kind of showing me, you know, where these main points should be and have an idea of what it should look like. Alright, so this next one you're going to try on your own. So convert to rectangular and graph. So you're going to try out R is -2 sine theta. Go ahead and pause it and sketch that. Okay, welcome back. Like the last one, if I have R sine theta, I can call that a Y. So I'll multiply both sides by R. So by substitution then, x squared plus y squared on the left side, -2y on the right side. So x squared plus y squared plus 2y, leave a little room, equals 0. And we complete the square. Half of 2 is 1, 1 squared is 1. So we have x squared plus y plus 1 quantity squared is worth 1 or 1 squared. So hopefully you drew a circle with a radius of 1 and centered on 0, -1. Don't have to go too far on this guy. So center on 0, -1 with a radius of 1. Alright, so one thing that's convenient to do on other graphs that don't end up as just circles or lines are using symmetry. So we'll start with looking about the polar axis. So remember, the polar axis is what used to be our positive x-axis. So basically something's moving from up here to down here. To test for that, replace theta with opposite of theta and see if we get back to the original. If we're looking for symmetry about the pole. So that's basically the version of the origin from our rectangular coordinate friends. For every r theta in the original, opposite r theta should also appear there. So for symmetric about the pole, we also have then a point back here at opposite of r theta. Now another type of symmetry that we remember from our college algebra days, symmetry about the y-axis. So here it would be symmetry about pi over 2. Theta equals pi over 2, I should say. So here's our pole, here's our polar axis, and we have some point here, and that is at r comma theta. If we're symmetric about theta is pi over 2, then we would also have a point, sort of the mirror image over here. Well, notice the radius would still be the same if we're looking at a mirror image here. And then this angle, instead of coming up from the 0 this way, we would be coming back from pi that way. So then our theta is replaced with pi minus theta. For some reason I wanted to put a comma there. All right, so some special shapes. First one, we'll do a cardioid. So what will form cardioids? R is a by 1 plus or minus cosine theta, or r is a by 1 plus or minus sine theta. So for example, if we get r equals 2 by 1 minus sine theta, we'll start by looking for any kind of symmetry. So opposite of r is worth 2 by 1 minus sine theta. So r is negative 2 by 1 minus sine theta. There's no way I can turn that back into the original. So that's not equal to the original, so not symmetric with respect to the pole. If I flip theta instead, r is 2 by 1 minus sine of opposite of theta. I can do a little bit of cleanup on that, but then that's r equals 2 by 1 plus sine theta, which is not equal to the original. So not symmetric with respect to polar axis. So then our sort of last ditch hope is replacing theta with pi minus theta. Okay, so sine of a minus b. So that's sine of a, cosine of b. And then we keep the sign in between and flip who gets what. So sine theta, cosine pi. Okay, so sine of pi is 0. These drop out. Cosine of theta is -1. So I have 1, 2, 3 negatives. That'll stay negative. And I have the sine of theta that is equal to the original. So this is symmetric. About theta is pi over 2. So since we're symmetric about theta is pi over 2, to sketch this, I would just plug in some key points from negative pi over 2 to pi over 2. So we'll continue this on the next page. And any of these other special shapes, anything that won't turn into just any kind of shape that we've already looked at from our, there we go. All right, got to that before it died. Awesome. Any of these specialty shapes, I'm not going to ask you to memorize what they'll look like or comparisons of A's and B's or things like that. I'm going to ask you to test it for symmetry and then know what points to plug in. What points should you try based on the symmetry that you find? So based on the symmetry being pi over 2, we'll just look from negative pi over 2 to pi over 2, calculating some r's based on those angles. So r, recall, is 2 by 1 minus sine theta. So sine of negative pi over 2 is -1. So r is 2 by 1 minus a -1 plus 1. So that is a radius of 4. And then we'll just go basically every 30 degrees from there. So we'll do negative